Hey everyone, my name is Urumuri Abraham with the topic about the pressure in the context of climatology. Here we are six members where everyone here has his or her point to talk about. The content as our point, as our objective, everyone will be able to define the pressure, to show the source of pressure, to rate pressure with humidity, to rate pressure with the crop's importance. Then we end with conclusion and the reference. Me with introduction, everyone will be able to define pressure in general, pressure in the context of climatology. Here, pressure defined as the force of area, where force is equal to the mass times acceleration. When the mass is for a solid, is what's called mechanical pressure. When the mass is for the fluid, is what's called hydrostatic pressure. When the mass is for air, is what's called atmospheric pressure. Here we have a unit for pressure, like millibars, which is most common used, which is equal to the 100 Pascal. Pascal is the standard unit for pressure. Here we have inches of mercury, which is the most common unit used in United States. You can measure pressure using some instrument like mercury barometer, which use mercury, or you can use digital barometer, which use sensors. Here also we have variation with altitude. Pressure vary with altitude or height. By moving up in atmosphere, the pressure will decrease. By moving down, the atmosphere will increase. Here at sea level, we have pressure which is equal to 1013.25 millibars. This data recorded in this situation where we have 15 degrees Celsius and this humidity, where there are no humidities. As you see, this data, this data where the atmospheric pressure increase, altitude decrease. Where the altitude increase, the atmospheric pressure decrease. It means where you have high altitude, you have a low pressure. Where you have a high pressure, you have low altitude, as shown here. Here you have barometric formula. This formula relates pressure with altitude or height. Here you have different values like P initial, T initial, R initial. This means we are in sea level. Most of what here they are known, except H and P, where H depends on P. As explained, all these values at sea level they are known. As you see, they are known. They are known. They have their values here, as you see, except H and P. Here H values depend on height, height taken. When height increase, the P will decrease, but depend on height taken here at the sea level. Here we have a high pressure and low pressure system. A high pressure system or anticyclones. This happens when we have high pressure at the center and low pressure around. Where air is compressed near the surface, which will do the circular flow of wind to the clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Where this is associated with clear skies, stable weather, and sink air. About lower pressure system or cyclone, here is where we have low pressure at the center and high pressure around, which will lead to the expand of air, then also lead to the circular flow of wind to the counterclockwise in the northern hemisphere, and clockwise in the southern hemisphere. This is also associated with the cloud skies, potential storms, and rising air. Impact on the weather and climate. Pressure causes wind form or shape which affect local and global circulation. And also pressure influences temperature, humidity, and precipitation. But not only pressure paths to estimate or to predict weather event or future event. Distribution of atmospheric pressure is that for vertical distribution. When you move up, the pressure will decrease. When you move down in atmosphere, the pressure will increase. Here about troposphere. Troposphere is where you have high pressure compared to other sphere because it's where weather occurs. About horizontal distribution depend on latitude, topography, and ocean currents. Uh, the next slide will be explained by my groupmate. To understand the pressure well, you need to follow all slide.
Thank you. My name is Norma Roforine. I'm going to continue with the source of pressure. The first point is about the solar heating. Solar heating is about how the radiation from the sun it's heat to the Earth surface. As you know, Earth surface is heated by the sunlight. This process is called solar heating. Equatorial region, which is closer to the sun, receive more direct sunlight. As the result, this area become warmer. Warmer air expand and become lighter, leading to the lower atmospheric pressure. In contrast, polar region receive less sunlight. The result is cold temperature. Cold air is denser and heavy. It leads to the high atmospheric pressure. So solar heating, which is one of the source of pressure, is like due to how the solar radiation from the sun is hit to the Earth's surface due to the observation and reflected. So this image shows how the solar radiation from the sun, its absorption and reflected, and how it's related to the pressure. So the second point is about the atmospheric composition. As you know, the air around us is made of different gases. The most commonly are nitrogen, oxygen, and water vapors. Those gases have a very concentration in atmosphere. So when there's more water vapor or other gases, it can impact the pressure gradiently in different regions due to how those gases are concentrated in atmosphere related to the pressure. Thus how atmospheric composition is the source of pressure. The third point is about the vertical motion. Vertical motion is about how the air is moving up and down like any elevator within the atmosphere. So when the warm air lies like in hot balloon, it creates the lower pressure area at the surface. Conversely, when the cold air sinks, like when you are balloon on the span full of a hot span, it leads to the high pressure. There's vertical movement influence the pressure patterns globally. So here it's vertical motion. As I said it can be the source of pressure due to how the air is hot or cold, or the air is moving up and down. It's related to the pressure. So vertical motion is another source of pressure. So let me continue about the Coriolis's effect, which is fourth point about the source of pressure. Coriolis is about the rotation of the Earth, is about how the Earth is moving left or the light or is moving up and down. So about the Coriolis effect, air can move to the right in the northern hemisphere and can move to the left in the southern hemisphere. So the diffraction that leads to the formation of pressure system, the Coriolis effect can be to the high pressure, which is anticyclone, due to the air sink and spread outward, and Coriolis effect can lead to the lower pressure system, which is cyclone, due to the air allies and converts the inward. So the pressure system influences the global wind pattern and weather phenomena. So the Coriolis effect, in summary, is about how the air is moving in different side, which is left or right. So it's really to the how the wind is moving can be lead to the heavy wind. So this is what I want to say about the source of pressure. Let me give my correct continue with another point, which is source of pressure.
Thank you. By name Sidra Pacific. I'm going to continue about source of pressure. So we are going to the point number D, which is called topograph. Yeah, this topograph, think of the Earth's surface feature like mountain, valleys, and coastlines. So they impact atmospheric pressure pattern in interesting ways. Orographic effects. Yeah, this is the point one. When air encounter a mountain range, it forced to rise. As they ascend, it cools and condenses, leading to the cloud formation and precipitation on the windward side. We have also local temperature variation. Coastal areas experience middle temperature due to the moderating influence of nearby oceans. Inland areas away from the oceans influence can have more extreme temperature changes. All these factors contribute to pressure difference across different regions. Yeah. Let us go to the point number E, which is called oceanic influence. So this oceanic influence also it's the source of the pressure we normally have. The ocean plays big role in shaping atmospheric pressure. So in the following ways: sea surface temperature, ocean currents, evaporation. So evaporation, this is happening when the sun hits the oceans, water evaporates and rises into the atmosphere. This adds moisture to the air and affects pressure patterns. So for the sea surface temperature, the warmth or coldness of the ocean surface affects nearby air. Warm oceans, water hits the air above them, causing it to rise. This rising air creates low pressure areas. So we have ocean currents. These ocean currents, these are like underwater highways. Warm currents carry heat from the equator towards the poles, influencing nearby air temperature, cold temperature due to opposite. Also, we have human activities. These human activities can also influence can also be a source of pressure in the following ways. What we do as human can direct impact atmospheric pressures. We have urbanization, industrialization, deforestation. So for urbanization, cities with concrete, asphalt, and building absorb and release heat differently than nature landscapes. These effects landscape local pressure patterns. Industrialization, factories emit pollutants and heat. These alter the air composition and temperature influence pressure. You know this industrialization also it affects pressure and source of pressure we normally have in this in this world. So, and we have also deforestation. As we know, deforestation is the cutting down trees. So this deforestation also changes land surface. Forests help regulate temperature and moisture. So their loss affects pressure. You know, when we cut down the trees, so we affect the pressure. They affect loss of pressure. So we have to avoid that. By understanding this factor, these factors help us to predict weather, model climate, and manage our environment. Oh, okay. Let us go to the relationship between atmospheric pressure and the humidity. Yeah. We go on the point of humidity. The relationship between atmospheric pressure and humidity. Number A, we have water vapor content. This water vapor content in the air varies depending on location and temperature. So the amount of water vapor in the air, it varies depending on the location and temperature. And also air has a capacity to hold the water vapor, which changes with temperature. So this water vapor capacity that holds water, it changes with temperature. At high temperature, air can hold more water, about 4%. In cold condition, the air capacity for water vapor decreases significantly to only about 0.2%. Okay, as humidity increases, more water vapor in the air, the overall mass of air molecules per volume decreases. You know that, I think. This decrease in air density affects atmospheric pressure. Let us go to the other point. We have density and pressure. Imagine a room filled with air. Let us imagine a room filled with air. Now let's add some water vapor. Those sneak water molecules to that air. When we add the water vapor, the total number of molecules in room increases. But here's the catch. To keep the pressure or temperature from going wild, the number of dry air molecules must decrease by the same amount. Okay, so as water vapor joins the mass of dry air per unit volume actually decreases. So when water vapor joins the mass of dry per unit volume actually is decreases. And guess what? This change in density affects the overall atmospheric pressure. Here is the image for more details about how density of air, ambient temperature, and decrease. This is the the left side. We have density, which is measured in kilogram per meter cube, and air pressure, which is measured in kilopascal. But we know the unit of pressure we normally use is pascals. Yeah, this how the graph on the curve is graphed, showing how density and air pressure varies. Density of air, ambient temperature, and pressure. Thank you for that.
Thank you. My name is Tishimira Didier. I'm going to continue with the point about pressure and temperature. The temperature and atmospheric pressure are body that they goes in hand to hand. When it hot, air molecule moves fast, creating high pressure. We can guess what? Humidity is a part of this question too. As temperature rises and air can hold more water vapor or humidity, so higher temperature means higher humidity capacity. That is why we can call it relative humidity. It means it's related to the temperature around us, aberration. Here I'm going to continue with another point, pressure and relative humidity. Relative humidity tells us how much water vapor in the air is compared to the maximum it could hold at a specific temperature. It means when the air is harsh, it can hold more cold. It's specific. Imagine, for example, imagine a sponge. If it is already soaked with water, humidity is full of 100%. It can absorb more water, and relative humidity is like saying here, how close are you being to full soaked sponge? It expressed as a percentage, and it can change with temperature as temperature change and relative humidity change. Temperature rules in pressure and relative humidity. When warm, it's like a spacious room. It holds more water. And when it's cooler, it cannot hold more. So the temperature rise, it can hold more water vapor that affect relative humidity. If it gets hotter, the relative humidity may decrease because the air can hold more water. The total pressure and saturation. When the overall pressure in a system increases, like squeezing a sponge, relative humidity goes up. Eventually, if you keep adding more water vapor, the air becomes fully saturated 100%, and at that point, extra water vapor is too cold formation or rain. Here are images which tell us the more details about relative humidity. How you can calculate it. Relative humidity equal to partial pressure over vapor pressure times 100%. When pure water is less than vapor water, there is evaporation. And when pure water is equal to vapor pressure, there is a saturation. When pure pressure is greater than vapor pressure, there is a condensation. There is a debate and a perspective which tell us the relationship between pressure and humidity. The first one is many scientists that there is a relation between atmospheric pressure and humidity. While the exact nature of this effect it isn't straightforward. Pressure likely doesn't impact relative humidity. Contrary to the pressure, some experts believe that pressure and humidity are unrelated. However, this perspective is less common. According to Dalton insight, John Dalton showed us in the 19th century that water vapor air does not interact with oxygen and nitrogen. Therefore, most humidity-related processes are independent of total air pressure. In practical, relative humidity sensor, the phytometer is a relative humidity sensor type sensitive to air pressure because air carries heat to the wet sensor and remove evaporated water vapor from it. Accuracy at altitude. To calculate relative humidity value at high altitude, one must account for atmospheric pressure using conversion equation or local pressure measurement. Then, the relationship between pressure and humidity remain a topic of debate, and understanding this factor is essential for comprehending climatology and its impact on our environment.
Hello, thank you. My name is Naniza Ismail. I'm going to talk about pressure and clouds importances. Atmospheric pressure, fundamental concept in climate sciences, affects various aspects of globes. It means that the atmospheric pressure has the roles or important to plants like in growth crops and in productivity of plant. like that. Understanding pressure dynamics in crucial for predicting weather patterns and optimizing agricultural practice like in crops cultivating in a greenhouse. So this figure shows how the water moves through a trees like in transpiration, cohesion and absorption. So in transpiration the water vapor evaporates from leaf to atmosphere. In cohesion, the water molecules and other molecules pass or moves to other parts of the upper part of the plant through the tracks like in leaves, branches, in fruits and like that. So in absorption, the water molecules or other molecules are absorbed from the roots from the soil to roots. The importance of pressure, especially in vapor pressure density or VPD in abbreviation related to collapse. The vapor pressure density. This is the process of or the differences of pressure in the plant and in the atmospheres. It is like a theater of world between the water inside the plants and the air around them. See the difference in vapor pressure, or basically how much water is in the air between the plant and its environment. It means that it is help to measure how the measure of the water evaporates inside of the plant or in the plant and in the atmosphere or in the environment. Why do why does this matter? Well, it affects some critical thinking, water flow, wall efficiency, and carbon fixation. So it means that VPD influences how water moves with the plant. For example, if the VPD or vapor pressure density is high, it means that it able to plant to move or to transport high amount of water. And if the VPD is low, the transport of or the movement of water is deficient. In the growth efficiency, when VPD is just right, plants will love efficiency. It means that when the VPD is high, the growth plant is efficient or is fast. But the VPD is low, the plant growth slow or the efficiency of growth is absent is present here. And the carbon fixation plant use carbon dioxide for photosynthesis process. VPD affect this process in how and it means that the VPD is low, the photosynthesis process is not do well, but the VPD is high, this process do better because of the pressure. So accurate control of VPT in like turning an instrument, it can lead to high yield or high production. For example, more veggies, fruits, or grains. It means that the VPD it helps to 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 know the high the quantity of the production. In the first glove plant or turbo mode like to grow faster or rapidly. Yeah. If the VPT is high, it help plant to grow well or faster. Better nutrient profiles. It means that if the VPT is high, it means that the soil or the plant has efficient nutrient or high on quantity nutrient. So there is some importance of vapor pressure deficit in plant physiology and how it can control it. In air, the first one is the plant physiology and VPD. Particular plant like feed crops plant. So it helps control environmental agriculture like a CEA system like in greenhouses. It means that it help to VPD, it help to plant to grow the plant in a fast and the water uptakes it help to absorb water uptakes plant absorb water from the root. This water contain essential nutrients for growth and for photosynthesis. It means that if the VPD is high, it means that the amount of nutrients in the soil is high. Those nutrients help us plant in growth and the photosynthesis process or and other process contained in a plant. Another is the transpiration. So as we have seen, transpiration is the how or the process where water vapor evaporates from the leaf to atmosphere. Yeah, like that. Leaves have more pores or tins, which is called stomata. This stomata is the where water vapor path or evaporate in order to go in the atmosphere through the process of transpiration. Through this, plant release gases, water vapor or transpiration. It is like their cooling system and keeps them tight or fins. So to vapor pressure different water flow within plant depends on pressure difference across different plant parts. So there are some effect of VPD. Like if the VPD is low, it means that the plant has a mineral deficiency, slowly growth, and low amount of nutrients. And if the VPD is high, it means that the minerals are high or efficient and the growth of the plant is faster and the growth wells and the process of photosynthesis do well and the growth and like that and the plant growth in fast like that. And thanks you.
Thank you. My name is Yuandeshimi Fabrice, and I'm going to continue for controlling vapor pressure deficit. The first one is outdoor challenges. Like in natural outdoor environment, controlling vapor pressure deficit is tough due to climate variations. The second one is controlled environments. A controlled environment in places like greenhouse, and we can precise manage vapor pressure deficit like how sensors, temperature and humidity sensors keep an eye on the air. The second one is automated systems. These adjust air flows and environmental condition based on sensor readings and technology tools. Another one is technology tools like data loggers and smart humidity controllers help to help regulate a vapor pressure deficit without manual fuse. And I'm going to continue with crop potence and pressure. About crop potence and pressure, we have the first point, which is optimal pressure range. In optimal pressure range, crops freeze within specific pressure range, and extremely pressure variations can harm crop health. Another point is irrigation consideration. For irrigation consideration, we have proper irrigation management account for pressure change and maintaining soil moisture during high pressure period is essential. As conclusion for our work, we have been understanding atmospheric pressure is crucial in climatology. It acts as foundation and or for comprehending weather patterns, climatic dynamics, and their impact on our environment. And we have talked about some key points like first, pressure in climate. Where in pressure in climate we have seen atmospheric pressure influenced altitude, temperature, geography, interact with other factors like humidity and wind patterns. Another is high pressure systems. High pressure systems bring stable weather, while low pressure systems lead to storms and challenges. Another key point I've talked about is crop impact. Like atmospheric pressure affect crop growth, photosynthesis, and overall health. In extreme pressure changes can stress crops and impact food security. Another key point I've talked about is climate change connection, like rising temperature, alter pressure patterns, leading to more intense external weather events, and incorporating pressure data into climate models, improve prediction and mitigation strategies. After all our work, we have the intellective quiz like some questions we can answer about what we have done. The first one, the first question we have is what is the impact of atmospheric pressure on weather and climate? The first impact of atmospheric pressure on weather and climate is change in atmospheric pressure, influence temperature, humidity, and precipitation. And the other, understanding pressure systems. Understanding pressure systems help meteorologists to predict weather condition. The second question is what is the distribution of atmospheric pressure? About distribution of atmospheric pressure, we have seen that there are two distribution: vertical distribution and horizontal distribution. In vertical distribution, pressure decreases with altitude. The troposphere, where weather occurs has two higher gradient. The second one is horizontal distribution, where pressure carries across earth surface due to factors like latitude, topography, and ocean currents. Another question we have seen is identify the sources of pressure. The first one, some sources of pressure. So the first one is topography. We have seen topography. We have seen solar heating. We have seen like human activities, and we have seen the like atmospheric composition and oceanic influence. And the fifth question is what are human activities that can cause pressure, or that can be the source of pressure? The answer for this question there are industrialization, like those industries can bring more temperature that can cause pressure. And we have seen urbanization can be the source of pressure. Is a human activity that can be the source of pressure. And the last one is deforestation, cutting down trees, and we know that forest help in decreases pressure in atmospheric pressure. Okay, thank you. That was our work.